All right, so let's do Unit 6, Checkpoint A corrections here. So what we're looking at, sorry, I'm checking the setting here. No. Okay, I'm going to go through all the problems, so fast forward to wherever you need to go. So number one, I'm going to do just examples. Okay, so I've got on here, here's a random question that compares to yours. It's not the exact same thing as yours, but it's pretty close. So number one, these, I can't multiply what's under the radical together because the radicals are not the same. That means I got to go to fractional exponents. Okay, so in this first one, make that a 3/4 power. This one would be a 1/3 power. And now that I got them in fractional exponents, since the bases match, I just need to add the exponents. So I'm really taking 3/4 plus 1/3, which if I make these twelfths, that'd be 9. If I multiply by 4, that'd be 4. So that'd be y to the 13 twelfths. And kind of a hint here, that's more than 1. So in my answer, I'm going to be able to have a y out front. I'm going to be able to factor out a y. But if I keep going with this, so this would be the 12th root of y to the 13th. Now, since there is at least 12 inside of here, because remember, for every group of 12, you can pull one out. So if I pull one group out, that'd be y on the outside, and then 12th root of y on the inside. Number two, I'll pick a few of these. I'm not going to do all of them because you kind of get the hint on these. But just look at these, like this first one here, when it has x to the 1/2. In my mind, I'm either thinking, okay, this is going to be the square root of x, which I look through the list, and I don't see that on there. So, okay, that must mean that one of these simplified back to this. So if I scan through these here, and like it looks like here, if I've got a power to a power, x to the 1/5 raised to the 5/2, you actually multiply those exponents. So this would be x to the, and then be 1/5 times 5/2. Cancel those out, that's x to the half. So you'd want to drag that to there, okay, and so on. So some other ones that might be like this one here. If you got 1 over the square root of x to the 5th, well, that'd be 1 over x to the, again, it's not written, that means it's a 2, so it'd be 5/2. Bring it up to the top, that'd be a negative 5/2. So remember all your exponent rules. If it's negative, you got to move it, and so on. Okay, so let's go on to number 3. So this guy here, if I want to simplify this, I would look for groups of 3 in here. So factor everything out. So like I got the, let's see, the cube root of negative 64, x 12, y 6. So 64 would be, 4 times 16, and then 4 times 4. I can keep factoring into 2, 2, 2, 2, but I see a group of the same number. So they don't necessarily have to be prime. They just have to be 3 of the same number. So I can pull a 4 out. It's a negative, and the only way to get a negative product is multiply a negative times a negative times a negative. So this would be a negative. And then x to the 12, how many groups of 3 are in there? There's 4 groups of 3. Y to the 6, there's 2 groups of 3. So 2 groups of 3. And then there's nothing left under the radical, so that'd be your answer. Number 4. Wish we were on 14, it'd be a lot faster. But number 4, I think the easiest way on this one is look at these guys right here first. Let's combine them. So if I'm dividing and I got the same base, it means I subtract the exponents. So this would be x to the negative 7/9 minus negative 4/9. So minus, and minus a negative is plus, and then y to the 1/2 is still hanging out there, and then negative 6. So if I simplify this, this will be negative 3/9, which is negative 1/3. And now when you got 2 things in here being taken to a power, they both get that power. So this would be x to the negative 1/3 to the negative 6th, y to the 1/2 to the negative 6. And when you do a power to a power, you actually multiply them together. So I'm going to do this. I'm going to save some space, let's put those over 1 and do my multiplying. The negative times a negative is a positive, and 6 over 3 is 2, so it'd be x squared. Here, this would reduce to 1 and 3, so positive times negative is negative, so that'd be negative, or y to the negative third. Can't have negative exponents, so this needs to move to the bottom like that. Okay, let's go to number 5. So number 5, again, fifth root, and then x 17, y 9, z 12. And basically for every group of 5, pull 1 out. So in here, 5, 5, and 5 is 15, so I can pull 3 out, but then there'd be 2 left over. So like 17 divided by 5 would be 3 remainder 2. Y divided by 5 is 1 remainder 4. And then 12 divided by 5 would be 2 remainder 2. Okay, so x cubed y z squared. It looks like this guy right here, so it'll be letter C on that one. Then number 6. Forgot to mark that number 5. But number 6, I can't add these together if they're different. It's like this is a cube root of 81, this is a cube root of 3. I can't add them. But if I do some simplifying, maybe I can. So 3 cube root of 81. 81 is 9 times 9, 3, 3, 3, 3. Cube root says look for a group of 3. I'm going to pull that 3 out front, times the 3 that's already there would be 9. Cube root of 3. Those two are like terms, so 9, 10, so it'll be 10 cube root of 3 minus radical 5. So that's your answer. Okay. Number 7, go like this. Number 7, since they're both cube roots, I can actually multiply what's underneath. You know, we couldn't do that in a previous problem, but now since they're both the same, they're both cube roots, this would be the cube root of, I'm just going to put 64 times 125. I don't need to know what the product is. I'm going to factor it anyway. And then m cubed times m cubed would be m to the 3 plus 3 is 6. So 64 is 8 times 8. 2 times 4, 2 times 4, 2 times 2 times 2. Okay, so for every group of 3 that you can find, you can pull 1 out. Okay, so I see a group here and another group. So I can pull a 2 out and a 2 out, which makes a 4. So it's going to be a 4 out front. And then, I don't need that. M to the 6, for every group of 3, you can pull 1 out. So I can pull 2 out. And I don't need it anymore. So 4 m squared. Just realized I didn't do the 125 yet. So that's why we're messed up here. But that's not on my list. So let's do this. So I'm not quite done yet. 125 would be 5 times 25, and then that's 5 and 5. There's another group, so pull a 5 out front. That makes sense. Okay, so if you do it correctly, you'll get the right answer. So that's letter B. Whew, close one. Number 8, let's see. Now if they're both, since they're both fifth roots, I can actually just divide underneath here. So if I take that top number divided by the bottom, it just becomes 3, 1, 2, 5. X to the 13th over x to the 3rd is x to the 10th. And then that would be y to the 16th. Now this is still all under a fifth root. One big fifth root. So let's do 3, 1, 2, 5. This would be 25 and 125. That's 5 and 5. 5 and 25. So it looks like there is a fifth root. If I took the fifth root, I'm going to have my calculator here. I'm going to try the fifth root of 3125 and see if I can find it. So the fifth root of 33125 is 5. So that comes out to be 5. 1, 2, 3, 4, 5. So it'll be 5. How many groups of 5 are here? There's 2. So I can pull 2 out. How many groups of 5 here would be 3, but there is 1 left over. 5x squared y cubed. Yep, so that's it. So it's letter D. Number 9. So to rationalize this, so if you have 42 over the cube root of 49, fastest way to do it, I can make this a rational number if I multiplied it by itself 3 times, because it's a cube root. So if I took whatever that cube root was and I multiplied it by itself 3 times, that's going to equal 49. But I got to do the same thing to the top too. So this would equal 42 cube root of, and 49 times 49, that's 7 times 7, 7 times 7. So I see a group of 3 in here I could pull out. So I could even pull a 7 out here. So pull a 7, 7 times 42, 42 times 7, do it on my calculator, is 294. Cube root of 7 over 49. And this would reduce to 6 and 1. So this would be 6 cube root of 7. So 6 cube root of 7 on that one. Let's go to number 10. So number 10, I need to rationalize the denominator. So 2 minus radical x over 5 plus radical x. Conjugate is 5 minus radical x. So on top, make sure you FOIL. So first would be 10. Outer would be a negative 2 radical x. Inner would be a negative 5 radical x. And then the last would be a positive x. On bottom, because they're conjugates, you can get away with doing the firsts and the last. So 5 times 5 is 25 minus x. Okay, and now look for what you can combine. So like here, I can combine those. So 10 minus 7 radical x plus x over 25 minus x. And there's nothing else I can do with that. There's nothing else to be simplified. So that's your answer. Number 11. Supposed to solve this guy. Now I want to get rid of this exponent, but before you do that, you want to make sure that the base and its exponent are by themselves. So first off, divide by 2. So this would be 27. Now I'm going to raise both sides to the 4/3 power. We got x minus 8 on the left side. And if you just want to let the calculator do it, you can. So 27 to the 4 divided by 3 power is 81. If you don't have a calculator to do it, remember the bottom number is a root. Okay, cube root of 27 is 3, 3 to the 4th. So 3 times 3 times 3 times 3, that's 9 times 9, which is 81. And then subtract 8 from that. So that would be, what, 73? Yeah, 73. Okay, that was 11. Now let's go to number 12. So I got the square root of x squared plus 7 equals x plus 1. I got the radical by itself, so I'm going to square both sides, x squared plus 7. When I square this, make sure you FOIL it, so it's x squared plus 2x plus 1. And when I subtract x squared from both sides and subtract 7 from both sides, you notice this side is 0 and I got 2x minus 6. And you think, uh-oh, what I do, I can't factor that. Well, it's okay because I'm trying to solve for x, so just add 6. And then divide by 2, so x equals 3. Let's see here. Oh, and I didn't mention, yeah, number 12, it says check for extraneous solutions. If I plug that back in, so 3, if I plug 3 in here and 3 in here, the original equation, maybe I'll do it here. Plug 3 here and 3 here. So on the left side, that'd be 3 squared is 9, 9 plus 7 is 16, the square root of 16 is 4. And then plug a 3 in here, 3 plus 1 is 4. So it checks out. So that's why I keep that one. Number 13, I've got the cube root of 2x minus 40. I'm going to bring the 2 to the other side. So it equals 2, positive 2. Now, to get rid of a cube root, you cube both sides. So 2x minus 40 would equal 8. Add 40. 2x equals 48 divided by 2. So x equals 24. Now, plug it back in. So 2 times 24 is 48. 48 minus 40 is 8. Cube root of 8 is 2. Minus 2 equals 0. So that one checks out. So that one works. Okay, number 14. A little bit, maybe I'll just write it on here. So number 14, it is a cube root, so it's an S shape. So right off the bat, these aren't in the right shape. I'm going to throw those out. And it's shifted 4 units to the right. Now they're both shifted about 4 units to the right. If I blew this up, you can see it better. But the positive S shape is like this. If this had a negative out front, it'd be like that. That's too drastic. More like that. So this one's out because it's not quite the right shape. It's a negative. This is not a negative up here. So because of that, letter D is your answer for number 14. Number 15. Again, let's look at this one. How's the graph of the cube root of x plus 6? So this is an S shape up 6 units. Okay, because it's got plus 6 on the end. So we're going to shift the graph 6 units up. And then which picture is that? One of these. And that's down. That's not shifted at all. That's 6 units up. So that A for number 15 is the one. Let's see if I get the right numbers now. So a couple more. 16. I guess I don't need this still. So number 16. So use the transformation. So if it's got a minus 6 on the end, that's down. I'm sorry, minus 3 on the end, that's down 3. A plus 2 means left 2. So it's going to be, since it's a cube root, it's going to be that S shape, but it's going to go left 2, down 3. So this is left and up, that's out. This is right and up, that's out. This is right and down, that's out. This is so left and down, so A is the one. And then number 17, it's a square root, so it's just that shape that goes like this. They all have the right shape. Now see which one has the right transformation. So minus 3 is down 3, plus 4 is left 4. So left 4, down 3. It's not this one, it's not this one. This is left. Let's see which one. So left 1, 2, 3. This is left 3, down 4. Backwards. We want left 4, down 3. So that's the one. And then number 18, I can do it on the paper here. So express, approximate, we don't need to approximate this. So if I convert it into a radical, the bottom number is a root, so the cube root of negative 125 to the 4th power. Do the root first. What times itself 3 times equals 125? And hopefully we're starting to see these numbers over and over and we're accidentally memorizing them. 5 times 5 times 5, and since it's a negative, it would be a negative. So this would be a negative 5 still to the 4th power. So I haven't done that yet. So now negative to the 4th power is going to be positive. So I can kind of forget about the sign for now. I know that it's going to be a positive. And then if I got 5 times 5 times 5 times 5, well, 5 times 5 is 25. And then multiply them together. So if you use a calculator, that's 625. If you just type it in your calculator, you get your answer. Okay? Hopefully this helps. Again, if you have any questions, you can still ask me, but hopefully this will help so you don't have to wait around for me to help you.